At a luncheon party for, we're doing number 8. At a luncheon party for 37 eminent personalities, that means the total number of people at the party was 37. That's the number of elements in the universal set. 25 requested for fried rice. Let F be the set of guests who requested for fried rice. 15 requested for salad. Let S be the set of guests who requested for salad. And 20 requested for shredded beef. Let me use B for the set of those are requested for shredded beef. 7 people requested for fried rice and salad. This is fried rice and salad. This is a cup for fried rice. This is a cup for salad. So all the people here are the people requested for fried rice and salad. So we'll see there's a combination of those are requested for fried rice and salad only, and those are requested for fried rice, salad, and beef. All the 3 dishes. So that means the number of elements in the set F intersection S for fried rice and salad is 7. Now 13 people requested for fried rice and shredded beef. That's his place. Fried rice, shredded beef is the whole of this. So number of elements in the set F intersection B is 13. Now those are requested for fried rice and shredded beef. It's a combination of those are requested for only fried rice and shredded beef, and those are requested for the 3 fried rice, salad, and shredded beef. So what else? 8 people requested for salad and shredded beef. This is salad and this is shredded beef. So those are requested for salad and shredded beef are all here, which is a combination of those are requested for only salad and shredded beef and fried rice, salad, and shredded beef, all the 3. So the number of elements in the set S intersection B is equal to 8. Now let's go. So also, what's the next thing? Also 8 people requested for salad and shredded beef. Also 10 people requested for fried rice only. That's the people here. Yeah, those are the people here. Those are requested for fried rice only. While 5 people requested for salad only. That's for salad only. Using a Venn diagram, find Roman figure 1 the number of people that requested for all the 3 dishes. Okay, Roman figure 1 number of people that requested for all the 3 dishes. Let X be the number of people that requested for all the 3 dishes. Let me say the beginning, that's Roman figure 1. Let the number of elements in the set F intersection S intersection B, which means the number of people requested for all the 3 dishes, be equal to X. If at X, I know that the whole of this F intersection S is 7. That means this will be 7 minus X. Those are requested for salad and fried rice and salad only. That will be 7 minus X. The whole of this represents those are requested for salad and shredded beef, and that's 8. So that means salad and shredded beef only will be 8 minus X. The whole of this represents those are requested for fried rice and shredded beef. So that means fried rice and shredded beef only will be 13 minus X, because 13 represents the whole of this. Those are requested for fried rice and shredded beef. So let's see what's the question now. How do we now find the number that requested for only for all the 3? How do we find X? Now let me find in this place. I know that if I add 13 minus X and 8 minus X together and subtract from 20, I'm going to get those who requested for only shredded beef. So that's what I'm going to do. The number of elements in the set F complement intersection S complement intersection B, that's the number of guests who requested for only shredded beef, will be equal to 20 minus the sum of 13 minus X, X, and 8 minus X. And that's equal to 20 minus X plus X is 0. 13 plus X is 21 minus X, which simply means 20 minus 21 plus x, and that's minus 1 plus x, which I can simply write as x minus 1. So the number of people who requested for shredded beef only is x minus 1. It's always good to find all of the to represent all the parts in the Venn diagram before you start answering questions. Now let's see, did they say there was anybody who did a request for any? Okay, they said assume that each person requested for at least one dish. So there was nobody who didn't ask for anything. That means there's nobody outside the 3 circles inside the rectangle, which means the set A union B, the set F union S union, the set F union S union B complement is empty. That would have been the people who didn't ask for any of the dishes. Now, so let's go. How do I now find x? I can say this plus this plus this plus this is equal to 25. I can use that to find x. Yes, I can use that to find x. Everything inside this circle that represents set F is going to give us 25. So if I add 10 to this, and this, I should get 25, and that's how I'm going to find x. So let's go. That's very simple. That simply means 10. Let me bring this diagram down so that I can see it as I write. So we have the diagram here. That's the diagram. And now I can say 10 plus x, 10 plus 7 minus x, 10 plus 7 minus x plus 13 minus x. That's the sum of everything inside the set F. 10 plus 7 minus x plus 13 minus x will be equal to 25, which means minus x plus x is 0, and that means 10 plus 7 is 17 plus 13 is 30. That means 30 minus x 30 minus x is equal to 25, which means 30 minus x equals 25, and that simply means minus x equals 25 minus 30, which simply means minus x equals minus 5, and that therefore means x equals 5. Therefore 5 people requested for all the dishes, requested for all the 3 dishes. 5 people requested for all the 3 dishes. I can remove that now. All the 3 dishes. Now let's go to Roman figure 2. What does that say? Find the number of people that requested for 2 different dishes only. 2 different dishes only will be those that got only fried rice and salad, plus those that got only fried rice and shredded beef, plus those that got only salad and shredded beef. And that will be 7 minus x plus 13 minus x plus 8 minus x. So that simply means, let's see, number that requested for 2 dishes only. 2 dishes only will be equal to, that's it, 7 minus x plus 13 minus x plus 8 minus x. 7 minus x plus 13 minus x plus 8 minus x. We showed that already. Only fried rice and salad, only fried rice and shredded beef, plus those that got only salad and shredded beef. And that's going to be 7 plus 13 is 20 plus 8, that's 28. 28 minus 3x, and that is 28 minus 3 times 5, which simply means 28 minus 15, and that's 13. Now to Roman figure 3. The number of people that requested for only one dish. Number that requested for only one dish. Only one dish. Number that requested for only one dish will be equal to those that got only fried rice. Only fried rice. Plus those that got only salad, plus those that got only shredded beef. And that will be 10 plus 5 plus x minus 1. That's 10 plus 5 plus x minus 1, which simply means 10 plus 5 plus x, which is 5 minus 1. And that's 10 plus 5, 15, plus 5, 20, minus 1, 19. That's 19. So 19 people requested for only one dish. So, okay, and that's it, very, very simply. Now let's do number 7. As part of his project, a final year student of music interviewed some undergraduate students on the type of music they liked listening to. 30 liked listening to jazz, 20 liked listening to reggae, while 20 also liked listening to funk. So there are 3 types of music: jazz, reggae, and funk. Jazz, reggae, and funk. Jazz, reggae, and funk. So this represents this circle represents the set. So let this be the universal set, which has all the number of students that were interviewed, all the undergraduates that were interviewed. This will represent the undergraduates that were interviewed. I can make that a little smaller. Yes, so that's the universal set U. That's the universal set U. They didn't tell us the total number of students that were interviewed. So how many liked listening to jazz? The number of elements in the set J for jazz is 30. And the number of elements in the set R for reggae is 20. While the number of elements in the set F for funk is also 20. Now they said 10 students liked listening to jazz and reggae. Jazz and reggae is the whole of this. Jazz, reggae, that's the whole of this. 10 liked listening to jazz and reggae. So the number of elements in the set J intersection R is 10. 10 liked listening to jazz and reggae. 10 liked listening to jazz and funk. The number of elements in the set J intersection F, jazz and funk. This is jazz and this is funk. Number of elements in the set J intersection F is also 10. What else? While 9 students liked listening to reggae and funk. That means the number of elements in the set R intersection F is 9. This is reggae and this is funk. It's a combination of those who listen to reggae and funk only and those who listen to all the 3. So let's go. Let's read further. If 3 students liked listening to all the 3 types of music and 32 did not like listening to any of the 3 types of music, 3 liked listening to all. Those are the people that will be here. And 32 did not like listening to any of the types of music. That will be those are the people that will be outside here. That's the number of elements in the set. J complement intersection R complement intersection F complement. Those who are still members, who are still undergraduates, but who don't like to listen to any of the different types of music. Now, what's the question? Question A says, find Roman figure 1, the number that likes listening to jazz only. Jazz only. First of all, we know that jazz and reggae is 10. So that means jazz and reggae only will be 10 minus 3, which is 7. We know that jazz and funk, those who listen to jazz and funk is 10. That means those who listen to jazz and funk only will be 10 minus 3, which is also 7. And we know that reggae and funk, those who listen to reggae and funk, all the people here they are 9. If 3 of them listen to all the 3 types of music, then those who listen to reggae and funk only will be 9 minus 3, which is 6. Now let me call this what do I now do to find those who listen to jazz only? Those are the people that are here. The people who listen to jazz only will just be those that are here plus 7 plus 3 plus 7. That means I can just do, I know that those who listen to jazz only plus those who listen to jazz and reggae only plus those who listen to jazz, reggae and funk plus those who listen to jazz and funk only will be 30. So that means to find those who listen to jazz only, I will just add 7, 3 and 7 together and subtract from 30, and that will give me the number that listen to jazz only. So I'm just going to say the number of people that students that listen to jazz only will be number of elements in the set J intersection R complement intersection F complement, which will be 30 minus 7 plus 3 plus 7, and that's equal to 30 minus 17, which is 13. So that means number that listen to jazz only is equal to 13. 13 students listen to jazz only. Now let's go. What's the next one? Roman figure 2. What does that say? The number that likes listening to reggae only. Reggae only is this place. Is the people that are here. Those that listen to reggae only are the people that are here. And that means if I add 7, 3 and 6 together and subtract from 20, I'll get the number of students who listen to reggae only. And that's what I'm going to do very quickly. So the number of elements in the set, that's J complement intersection R intersection F complement. That will be equal to 20 minus the sum of 7, 3 and 6. 20 minus 7 plus 3 plus 6, which is equal to 20 minus 16, and that's 4. So reggae only will be equal to 4 students. 4 students liked listening to reggae only. Now let's go. What does the next one say? The number that likes listening to funk only. The number that likes listening to funk only. That will be the people here. And that's simply 20 minus the sum of 7, 3 and 6. That's the number that likes listening to funk only. So I can just say funk only, Roman figure 3, funk only is equal to 20 minus 7 plus 3 plus 6. 20 minus 7 plus 3 plus 6, and that's 20 minus 16, which is 4 students. Now what's the next question, which I think is the last? Roman figure 4. Find the total number of undergraduate students that were interviewed. Total number of undergraduate students that were interviewed will now be all of the students interviewed. Those are likely listening to jazz only, that's 13, plus this represents those are listening to reggae only, and that's 4, while this represents those are listening to funk only, 4. So the total number of students that were interviewed, undergraduate students that were interviewed, will be 13 plus 7 plus 7 plus 7, and that's 30 actually. So that will be this is how you add so that you don't make mistakes and you don't add any number twice. Add everything inside one circle together, and then the other things in the other circles, 1, 2, 3, and whatever is outside the 3 circles but inside the rectangle. And if there's nothing outside the 3 circles, then you just have everything here inside the first circle plus this plus this plus this to add together, and that will give you the total number of elements in the universal set, which in this case is the total number of undergraduate students that were interviewed. So that's simply total number of students interviewed, total number, let me just write that as let me just write this way: number of students interviewed, total number of students interviewed, total number of students interviewed will be equal to 13 plus 7 plus 3 plus 7. We know that that's 30, but let me just write it that way: 13 plus 7 plus 3 plus 7 plus 4 plus 6 plus 4 plus 32 plus 4 plus 6 plus 4 plus 32 plus 4 plus 6 plus 4 plus 32. I can even bring the diagram down so that we see that we are adding correctly. Let's bring the diagram down and be sure that we are doing the right thing. So that's it. This is a diagram. Yes, I think it's better this way. So these are the numbers we're adding: 13 plus 7 plus 3 plus 7, that's the whole of this, plus 4 plus 6 plus 4 plus 32, and that's the whole of this. So what does that give us? We can now check. Let's take that out and now see what that's going to be. So I know that 13, so that will be equal to 13 plus 7, 20, 23, 30, 34, 40, 44 plus 32, that's 76. How about correct? Let's do that again. 13 plus 7 is 20, plus 3 is 23, plus 7 is 30, plus 4 is 34, plus 6 is 40, plus 4 is 44, and plus 72 is, plus 32 is 76. So the total number of undergraduate students that were interviewed was 76. And I think that's it. Finally, it says, yeah, and that's it. Very, very simply. A survey carried out recently to find the number of applicants that applied for jobs into 3 newspaper establishments revealed that 70 applied to Daily Times, 65 applied to Daily Graphics, and 85 applied to Daily Punch. So let's have that. 70 applied to Daily Times, 70 applied to Daily Times. Let's put all of them there. Daily Times 70. So this is going to be the universal. This is going to be the universal set. That's it. We don't know the total number of candidates, the total number of applicants. So this is the universal set. 70 applied to Daily Times. D for the set of applicants that applied to Daily Times. 65 applied to Daily Graphic. G for the set of applicants that applied to 65. That means the number of elements in the set G is 65. And Punch, Daily Punch, P for the set of applicants that applied to Daily Punch. 85 applied to Daily Punch. Let's read further. 40 applied to Daily Times only. Daily Times only. That's the number of people that are here. 40 applied to Daily Times only. 20 applied to Daily Graphic only. The people here are those that applied to Daily Graphic only, while 45 applied to Daily Punch only. The people here represent those that applied to Daily Punch only. If 15 applied to all the 3 newspaper establishments, find Roman figure 1. Let me start with Roman figure 1. The number that applied to both Daily Times and Daily Graphic. That means we want to find the people that applied to Daily Times and Daily Graphic. This curve is for Daily Times and this is for Daily Graphic. So those that apply to Daily Times and Daily Graphic are the people that are in the whole of this place, which is a combination of those that applied to Daily Times and Daily Graphic only and those that applied to all the 3 newspaper establishments. So I need to know this place. I need to know the people here and add them to 15 to know the people that applied to both to Daily Times and Daily Graphic. So let this be A and let this be B, while this is C. We need to find all of the parts in the Venn diagram, represent all the parts in the Venn diagram before we start answering the questions. That makes it a lot easier. Now, how do I find A, B, and C? I know that A plus B, let me write my A well. A plus B, A plus, okay, I just know that 40, I know that 40 plus A plus 15 plus B, everything inside the circle will be equal to 70. So that means 40 plus A plus 15 plus B is equal to 70. And that simply means A plus B is equal to, that simply means A plus B is equal to 40 plus 15 is 55. When you take it to the other side, it becomes 70 minus 55. A plus B equals 70 minus 55. And that means A plus B is equal to 15. Let's call that equation 1. Now, the whole of this is 85. So that means 45 plus B plus 15 plus C is equal to 85, which means B plus C equals 85. 45 plus 15 is 60. 85 minus 60, and that means B plus C equals 25. Let's call that equation 2. The whole of this is also equal to 65. So that means 20 plus A plus 15 plus C is equal to 65. Yes, which simply means A plus C equals 65. 20 plus 15 is 35. So A plus C is 65 minus 35, which means A plus C equals 30. That's equation 3. Now let's solve for A, B, and C. From equation 1, I can see that, let's see, okay, from equation 3, I can say A is going to be equal to 30 minus C. So if I put A in equation 1, if I put A in equation 2, if I put A in equation 2, what do I have? No, there's no A in equation 2. If I put A in equation 1, what do I have? Putting A in equation, putting A in 1. If I put A in equation 1, this is equation 1, A plus B equals 15. So that means 30 minus C plus B equals 15. And that simply means minus C plus B equals 15 minus 30. I can write minus C plus B as B minus C equals 15 minus 30 is minus 15. So that's equation 4. Now I can solve equations 2 and 4 simultaneously because they are both in terms of B and C. Equation 2 is B plus C equals 25. Yes. While equation 4 is B minus C equals minus 15. So I can subtract to eliminate B. B minus B. B minus B is 0. C minus C means C plus C, which is 2C. 25 minus minus 15 is the same as 25 plus 15, which is 40. And that means C equals 20. So if C is 20, then I can find A. A will be 30 minus 20, which is equal to 10. Now what else do we need? Let me put C in equation 2. B plus C equals 25. That's equation 2. B plus C equals 25, and that simply means B plus 20 is equal to 25. This is 10, which means B equals 25 minus 20, and that means B equals 5. So we can now answer the question. The question says find the number that applied to both daily times and daily graphic. Maybe before we do that, I can do this. Okay, let's even just go. Let me bring the diagram down so that I can use it to answer the questions. Now, how do we find the number that applied to both daily times and daily graphic? So daily times, daily times and daily graphic daily times and daily graphic is equal to A plus 15, which is, what is A? A is 10. That's 10 plus 15, and that's equal to, I want to move this down, and that's 25. That means 25 applicants applied to daily times and daily graphic. Roman figure 2, find the number that applied to daily times and daily punch. Daily times and daily punch is equal to, daily times and daily punch will be, this is daily times, or this is daily punch, that's B plus 15. The whole of this, B plus 15. That's B plus 15. B plus 15, which is equal to, what is B? B is 5. That's 5 plus 15, and that's 20. Now let's go to the third one, Roman figure 3. What does that say? Number that applied to, Roman figure 3. The number that applied to daily graphic and daily punch. Daily graphic and daily punch. Daily graphic and daily punch. That's the whole of this. This is daily graphic and this is daily punch, and this is daily punch. So that's 15 plus C. Number that applied to daily graphic and daily punch will be equal to 15 plus C. Wow, and that is 15 plus, let's check C. C is 20. 15 plus 20, which is equal to 35. And now to, I think that's the last one, Roman figure 4. Roman figure 4, and that says the number that applied to at least one newspaper establishment. The number that applied to at least one newspaper establishment will be the total number of applicants, which is the total number of elements in the universal set. That's 40 plus A plus 15 plus B plus 20 plus C plus 45. There was nobody who didn't apply to at least one of the newspaper establishments. So that's the trick. Add everything inside one circle first before adding the rest, so that you don't add anything twice. 1, 2, 3, 40 plus A plus 15 plus B, and then you add this ones, plus 20 plus C plus 45. If there's anything there, you add it, but here there's nothing outside, there's nothing here. So number that applied to total number of applicants, that's the total number that applied to at least one newspaper establishment, will now be equal to 40 plus A plus 15 plus B plus 20 plus C plus 45, and that's equal to 40 plus, what's A? Let's check that. A is, what A is 10, 40 plus 10 plus 15 plus B, what B is 5 plus 5 plus 20 plus C, what C is also 20 plus 20 plus 45, and that will be equal to, I can remove this down, and that will be equal to, let's go, 40 plus 10 is 50 plus 15 is 65 plus 5 is 70 plus 20 is 90 plus another 20 is 110 plus 45 is 155, and that's equal to 155, and that therefore means the total number that applied to at least one newspaper establishment is 155, and that's it. The members of a college staff club were asked to indicate the brands of beer they drank. 5 members drank Star and Trophy beers, 7 members drank Star and Club beers, while 10 members drank Trophy and Club beers. That means there are 3 brands: Trophy, Star, and Club. Let's have that. This is a universal set. Trophy, Star, and Club. Let me make the 3 sets now. So let this be the number, let it be the set that represents Star beer, and this the set that represents Trophy beer, and this is the set that represents Club beer. Now they said 7 members drank Star and 5 members drank Star and Trophy beer. That means S intersection T is 5. 5 members drank, number of elements in the set S intersection T is 5. 7 members drank Star and Club beer. This is Star beer and this is Club beer. Everything, the whole of the people here are 7. That will be those that drank Star and Trophy beer only, Star and Club beer only, plus those that drank Star, Club, and Trophy beers. So a number of elements in the set S intersection C is equal to 7. 7 members drank Star and Club beers, while 10 members drank Trophy and Club beers. This is Trophy, this curve represents Trophy beer, and this curve represents Club beer. So everything inside here is going to be 10, which is a combination of those that drank Trophy and Club beer only and those that drank all the 3 beers. So 10 members drank Trophy and Club beer. That means the number of elements in the set T intersection C is 10. Now 6 members drank Star beer only, 6. 11 members drank Trophy beer only, that's 11. While 5 drank Club beer only, this will be 5. 3 members drank all the 3 brands, that's 3. Assuming that each member drank at least one brand of beer, find Roman figure 1. Let this be Roman figure 1. Find Roman figure 1 the number of members that drank Star beer. The number of members that drank Star beer will be all the elements inside the set S. That will be the number of members that drank Star beer. So what do I do? Let me make this. Okay, they already said 5 members drank Star and Trophy. The whole of this is 5. So if this is 3, that simply means this will be 2. 7 members drank Star and Club beer. That means the whole of this is 7. So if this is 3, that means this will be 7 minus 3, 4. That means 4 members drank only Star and Club. They said 10, and they said 10 members drank Trophy and Club beers. That means the whole of this is 10, which means those that drank Trophy and Club beer only will be 10 minus 3, and that's 7. Now how do we find the number of members that drank Star beer? Star beer will now be, number of members that drank Star beer will now be 6 plus 2 plus 3 plus 4. That's actually the number of elements in the set S. That's 6 plus 2 plus 3 plus 4, which is equal to, that's 8, 11, 15. So 15 members drank star beer. Let's go to Roman figure 2. Roman figure 2 says the number of members that drank trophy beer, that's the number of elements in the set T. Number of members that drank trophy beer will be 11 plus 2 plus 3 plus 7, which is 11 plus 2 plus 3 plus 7, and that's equal to 11 plus 2 13, 13 plus 3 16, 16 plus 7 23. That means 23 members drank trophy beer. Roman figure 3, what does that say? The number of members that drank club beer, that's the total number of elements in the set C, and that will be club beer. The number of members that drank club beer is equal to, club beer is equal to 4 plus 3 plus 7, 4 plus 3 plus 7 plus 5, 4 plus 3 plus 7 plus 5, 4 plus 3 plus 7 plus 5, and that's equal to 4 plus 3 7 plus 7 14, 14 plus 5, that's 19. Now to the next one, which is Roman figure 4. Roman figure 4, what does that say? Find the total number of members in the club. Total number of members. Total number of members will now be equal to, that's the sum of, that's what's it called, everything all together. This is a trick so that I don't make mistakes. Add everything inside one of the sets together. That's 6 plus 2 plus 3 plus 4, and you add the remaining things to the result. We already know that there was nobody who didn't drink at least one brand of beer, so the total number of members at the club will now be 6 plus 2 plus 3 plus 4, 6 plus 2 plus 3 plus 4. We even already know that that's 15. That's the total number of elements in the set S, but I'm adding it this way so that I don't get confused. Now we add 11, 7 and 5, so plus 11 plus 7 plus 5, and that will be equal to 6 plus 2 is 8, plus 3 is 11, plus 4 is 15, plus 11 is 26, plus 7 is 33, plus 5 is 38, and that's 38. That simply means the total number of members at the club was 38, and that's it. Very, very simply. Now we can go to the next one. In a senior secondary school, 80 students play hockey or football. The number that play football is 5 more than twice the number that play hockey. Okay, let's go to that. Let this be the universal set. In a senior secondary school, 80 students play hockey or football. That means the number of elements in the universal set is 80. 80 students play hockey or football. Let this be the set of students that play. Let that be the set of students that play hockey, and this be the second circle represent the set of students that play football. Now the question says the number that play football is 5 more than twice the number that play hockey. So that means if this is the number that play is 5 more than twice the number that play hockey, the number of elements in the set H, let that be H. Now the number that play football is 5 more than twice the number that play hockey. Twice the number that play hockey is 2H. 5 more than that will be 2H plus 5. And they said the number that play football is 5 more than, the number that play football is 5 more than twice the number that play hockey. That simply means the number of elements in the set F is equal to 2H plus 5. And now let's read further. If 15 students play both games and every student in the school plays at least one game, 15 students play both games and all of them play at least, every student plays at least one game, so there will be nothing outside here. Now find Roman figure 1, the number of students that play football. That means we want to find the number of elements in the set F. Now, if 15 students play both games, that means the number of students that play only football will be 2h plus 5 minus 15, while the number of students that play only hockey will be h minus 15. Now, how do we find the number that play? Let me say this is Roman figure 1. We're finding the number of students that play football. So I already know that simply means if I add this together, all of this together, those that play only hockey, those that play only football and hockey, those that play only football, if I add all of that together, I'm going to get 80. Now let's do that. H minus 15 plus 15 plus 2h plus 2h plus 5, you have to be careful, minus 15, that should give us 80. And that simply means minus 15 plus 15 is 0, and I know that h plus 2h is 3h. 5 minus 15 is minus 10. When it goes to the other side, it becomes plus 10. So that means 3h equals 80 plus 10, which means 3h equals 90. 3h equals 90, and that simply means h equals 30. So that therefore means number that play football is equal to, I already know that that's 2h plus 5. That's it. That's the total number of elements in the set F. 2h plus 5, which is equal to 2 times 30 plus 5, and that's 60 plus 5, which is 65. Now let's go to Roman figure 2. Find the number of students that play football but not hockey. Number of students that play football but not hockey will be the number of students that play only football, and those are the people here. That's actually number of elements in the set H complement intersection F. That's a set notation for that. So number that play football but not hockey. Will be equal to, number that play football but not hockey is 2h plus 15 plus 5 minus 15. 2h plus 5 minus 15, and we already know that 2h plus 5 is 65. So that means 65 minus 15, which is 50. I hope that's correct. That's 50. Now to the next one, Roman figure 3. Find the number of students that play hockey but not football. That's the number of elements in the set H intersection F complement. Those are the people that will be here. Now that means number that play hockey but not football will be equal to, it is h minus 15, and that simply means 30 minus 15, which is equal to 15. And that's it, very, very simply.